adding and subtracting rational expressions. We spent a little bit of time talking on Friday about what the rules are in order to add fractions. What's the one thing that we need if we want to add two fractions together? Common denominator, absolutely. So we're going to be working to get a common denominator and to decide what is necessary to have a common denominator. Okay, we're going to remember the LCM, the least common multiple. So first example, we wanted to know how to find the sum or difference. So the very first thing you have to ask yourself is, do they have a common denominator? If the answer is yes, then you combine like terms and put them over that common denominator. So what will our answer be for number 1, Jordan? 7 over 21x. I like it. Because 5 and 2 are over a common denominator, so we will add the numerators, put them over 21x, and then ask ourselves, are we finished? No. Dawson's shaking his head no. Why not, Dawson? We need to divide because 7 and 21 have something in common. What do they have in common? A 3. So if I factor or divide out a 3 from 7, or a 7 from a 7 in common, someone led me down the wrong path. If we divide a 7 out of the numerator, what do we have left? A 1. So we have to hold that place with a 1. And if we divide 21x by 7, we get 3x. That's our denominator. So this is your final answer. Okay. Letter B on your next, on this first example on your guided notes says we want to add 4x over x minus 3 minus 3 over x minus 3. So be careful of that sign in the middle. It's easy to forget it and neglect it. Okay, so Ben, what are we going to get when we combine these two? Absolutely. Common denominator makes it so easy. Add the numerators or subtract, right? And then use our common denominator, 4x minus 3 and x minus 5. So we ask ourselves, are we done? Is there any way that 4x minus 3 has a factor that of x minus 5 so we can cancel? No, so we're done. Okay? All right. So next example then, it's going to up the ante a little bit. We won't have a common denominator. We'll have to get that first. So in order to get common denominators, we have to know what the least common multiple is. Okay, what is one of everything? We want to gather one of everything up. Okay, so our next example says find the least common multiple of 6x squared minus 54 and 9x squared minus 54x plus 81. How will we approach this one? Yep. Veronica's making parentheses. She's trying to factor these guys out. So what do 6x squared minus 54, two terms, right? So we know we either have to GCF, find the greatest common factor, or difference of two squares. So what are we going to try with this one? They have a greatest common factor? Yep, what is the greatest common factor of 6x squared minus 54? 6. So if we factor a 6 out, we're left with x squared minus what? 9. X squared minus 9. Okay. Can that be further factored? We have a difference of squares, right? So we keep our 6, and then we have an x and an x, and what? Minus 3 plus 3. All right, so that was our first term. Okay. Now we have a second polynomial. We want to factor it out. What do they have in common? A 9. So we're going to take the 9 out. What will be left? I like it. So now we ask ourselves, are we finished with that one, or can it be factored? 3 terms, so we're going to try our t-chart, right? What are factors of 9 that add to become a negative 6? Negative 3, negative 3. All right, so GCF-wise, we need to gather one of everything. 6 is 2 times 3, and 9 is 3 squared, 3 times 3. So we need Okay, 2 and 2 3s. Okay, what is 2 times 3 times 3? 9 times 2 is 18, right? Okay, so we need an 18 to have one of every number. Okay, at least one of every number. Okay, what do they have in common as far as binomials are concerned? I see an x minus 3 in each one, right? But can I just gather one, or do I need two? LCM, you've got to have them both. Okay, so if we were finding a common denominator for these guys, we'd have to have two of those x minus 3s. And you're welcome to write it as x minus 3 quantity squared to save some pencil lead. Okay, or you can write it as x minus 3 times x minus 3. And then what's the last thing we need to gather up if we're gathering one of everything? An x plus 3. This is the least common multiple of both of those factors. Okay, saves us from gathering all of this and all of this. We just gather one of everything, a minimum of everything that we need. And when there are two, we have to make sure we cover our bases and get two of those x minus 3s. Okay, questions on this slide? All right, next slide then says find the sum. So now we want to use that, what we just did, finding that least common multiple, to figure out what the sum of these guys are. So 12x squared, pretty self-explanatory. It's kind of already factored, isn't it? But what about this second one? X squared plus 1. How's that going to factor, Christian? What do they both have in common? X. So we'll take the x out, and what's going to be left inside? If I divide a positive x by x, I'll get, yep, exactly. Okay, so in order to have a common denominator, this guy has an x and an x plus 1. Okay, does this one already have an x? Does it have an x plus 1? No. So it has to be multiplied by x plus 1 to have a common denominator. Okay? Now, this one has an x and an x plus 1. Does it have a 12? Missing a 12, isn't it? Okay, so we need to multiply it by 12. Does it have an x squared? In factored form, does it have an x squared? Just an x, right? So what's it missing? One more x. Okay, so it's going to be multiplied by x over x. Okay, Macy, put the phone away, write this down. Okay, so now everybody, we have enough of everything to be able to simplify. So on the first one, we're taking 8 times that x plus 1. Okay, common denominator will be 12x squared times x plus 1. That's our least common multiple of everybody. Okay, and what is that second numerator being taken times? 12x. So 12x times x is going to be 12x squared. Okay. What happens when I take 8 times x? I get 8x. When I take 8 times 1, I get 8. And we're used to putting our expressions in lowest or descending powers of x, right? So let's put our 12x squared in front. And what's our common denominator? Okay. Now, are we finished? No, I see some factors, right? What number does the numerator have in common with the denominator? 4, right? Okay, so we need to take a 4 out. And 12 divided by 4 is, so 3x squared. 8 divided by 4 is, so 2x. And 8 divided by 4 again is 2. And I still have my 12x squared down here. And then now we can cancel. 4 divided by 4 is 1. 12 divided by 4 is 3. So I'd have a 3x squared, x plus 1 in the denominator. Okay. It would be nice if we could get rid of the 3x squared, but remember that the minus or the plus signs fuse them together. So the only way we can cancel is if they're factors, if they're products. Have to have a multiplication sign or a parentheses in between. Very tempting to want to cancel those out. So the only other thing we could do is ask ourselves, is there any way that this is going to become an x plus 1? And it's not, so we're not going to cancel. Now, we could have saved ourselves a little bit of time if we had noticed at the very beginning, what do 8 and 12 have in common? A 4. So had we noticed this ahead of time, we could have canceled the 8, had a 2, canceled the 12, and gotten a 3, and then work it out from there. And we wouldn't have had to do this last factor cancel part. Make sense? Okay, what questions do you have on this slide? Good so far? Okay. All right, find the difference. Is there anything that we can do to make our lives easier up front with this one? Nothing cancels, right? But do you see that minus sign in front of the negative 2x minus 1? Would it be okay to multiply that through and have a plus and positives? That makes sense to everybody? Okay, so let's do a little foresight here and say if this is a minus, then I will have a plus 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 if I multiply that negative 1 through to everybody behind it. Is everybody cool with that? All right, so what's the next step? Yeah, factor it out, absolutely. So what is going to factor in the denominator of that first term? 3 terms, right? So we're thinking t-chart. What are factors of 2 that add to become negative 3? Negative 2 and negative 1. So we'll have x minus 2, x minus 1 with a 5x minus 1 on top. Okay. Now we put our plus sign in the middle. What are the factors in the denominator? What's the GCF of 2x minus 4, Caitlin? Caitlin? 2, right? Okay, so we take the 2 out. What's left? Perfect, x minus 2. Okay, and we still have a positive 2x plus 1 on top. Okay, now we're going to gather things up. So what do we need? Are we missing anything that's in the second denominator in this first denominator? What's missing? We have, this one has an x minus 2 and an x minus 1. What's missing from the second denominator? I see the x minus 2, right? But what's it missing? A 2. So we're going to have to multiply the first one by 2 over 2. We could if they weren't fused together, or if there was a 2 in that second spot that we could factor out. Okay, that plus sign says these are two terms. You have to either pull something out by factoring to cancel, or you can't cancel. Okay, and then now this will have a 2 times an x minus 2 times an x minus 1. So we're almost there. What's this one missing? An x minus 1. So if I multiply the denominator by x minus 1, now I have my common denominator. That means I have to multiply the numerator by x minus 1 as well. Otherwise, I'm changing it. I have to multiply by 1. Okay? So now we distribute. So, Manny, what will we get if I take 2 times the quantity 5x minus 1? Very good. Okay, so I've got 10x minus 2. I have a great big denominator here with my 2, my x minus 2, and my x minus 1. Plus sign in the middle. Okay. And let's pick on Jamie. Would you FOIL out this one for me? Two x squared minus 2x, 1x, and what's the sign? Minus 1. Okay. We're good so far? So let's combine our like terms in the numerator. And let's write them in descending powers of x. So my biggest power of x is 2x squared. Taking care of that one. I have 10x minus 2x plus 1x gets me a total of 9x. And number-wise, I have this constants, a negative 2 and a negative 1 for a total of negative 3. And in the bottom, 2 times the quantity x minus 2 times the quantity x minus 1. When we are combining the like terms, only when we're adding, we don't change the power. On the bottom, would you FOIL it out? You could, but there's no need to. Just leave it in factored form. Okay. Because the x's were already out in front. We're at. Oh, okay, gotcha. Let me go one more back. Only because the only reason we had the squared was because there were exactly two identical ones from this factor. Okay, so because there were two identical ones, we had to gather both of those up and one of these. These two took care of this one, then we had to add one of those and then the common factor of 18. Okay, so on this one, because they're not exactly the same, x minus 2, if it would have been x minus 2, x minus 2, we could just call it x minus 2 quantity squared. Okay? Is there any way this is going to factor into x minus 2 or x minus 1? Nope, so we're done. And there's no need to FOIL everything out, just leave it in factored form. Okay? So far, so good? Other questions on this slide? Okay? All right, so now, last example says, let's take our rational function, that's 5x minus 13 over x plus 2, and rewrite it into the form that we're used to so that we can figure out what the asymptotes are by looking at them. How did we do it back a couple sections ago? They remember that long process? We divided, long division, remember? And then whatever the remainder was our k. Okay? There's another way to do it. you want to see the long division quick so we remember how to do that? Or do you want to see the other way? Okay. All right. So we have g of x is 5x plus 13 over x plus 2. Okay. Just as we can combine things over a common denominator, we can split them off. Okay, we can make two fractions instead of just one. So it would be really nice if this was 5 times an x plus 2. Five times parentheses x plus 2. Okay, and I'll show you why. If this was 5 times x plus 2, then we could put it over the x plus 2, and we could cancel those two guys. Does that make sense? And 5 would be my k. All right, so what do we have to do to make this 5 times x plus 2? When I take 5 times x plus 2, what do I get? 5x plus 10, okay? So this would be really nice if this were 5x plus 10 over x plus 2. Isn't 5x plus 10 plus 3 the same thing as 5x plus 13? Okay? So far so good. I didn't lose anybody there. Okay? So we're projecting what we want, and we're saying let's rewrite it in that way. Now let's write it as two separate fractions. Okay? I'm going to rewrite this as 5x plus 10 over the x plus 2 plus 3 over x plus 2. Write it over as separate common denominators. Have I done anything illegal there? No, because if I wanted to, I could put them back together over the same common denominator and get 5x plus 13, right? Okay. But now, this is much nicer because this factors into 5x plus 2 over x plus 2 and 3 over x plus 2. What happens in this first equation, or first fraction? They cancel. So my g of x is now, let's write this one first, 3 over x plus 2 plus 5. A over x minus h plus k. So what is my vertical asymptote? Which one is it, up and down? What's my h? X equals -2 is my vertical asymptote. What's my horizontal asymptote? Y equals 5. So I make my dashes at -2 to draw my asymptotes, and then one at 5. Right? And is it reflected or is it normal? Normal, okay? And so if it were a 1 on top of my fraction, I would know that I just move 1 over and 1 up to see how close I get to that, to the intersection of those asymptotes, but it's 3, so I'm going to be a little bit further out. Okay, the square root of 3 out, in fact. And away I go. A little bit more than 1 out. The square root of 3 out. And away we go. Okay. Now remember, we could have looked at those coefficients, right? And decided what my vertical asymptote was going to be. 5 over 1 gets me 5, right? But we don't know if it's flipped or not. So x equals 5, or y equals 5 is our vertical asymptote, horizontal asymptote. X equals -2, what makes the denominator 0. But then we would have had to try a point to see where it's going to be. So when x is 0, 0 plus 13 over 0 plus 2, 13 over 2 is 6.5. If I'm 0 over, I'm 6.5 up, so I'm not quite where I should have been. Okay? Many different ways to work these. All right. So you have a sheet in front of you. We worked the ones in the boxes. So you have 10 problems is all, 11 problems is all to do yourself. Okay? And then we'll spend some more time on this tomorrow. So work through it, figure it out, and then we'll have a little bit more time tomorrow on this. Not on this particular one, a new worksheet. So we want to have this done when you come back tomorrow. Okay?